Welcome to Pepperl+Fuchs Plugged In, where automation professionals can stay in touch with the latest enhancements in sensing, data communication, and control.
Hello and welcome everybody. This is Pepperl+Fuchs Plugged In, and today we have a special episode with Jim Bashirs. Hi, Jim.
Hi, Helga.
How are you doing, Jim, today? How's it going?
Pretty good.
All right, Jim, today we're talking about some fairly innovative technology for mobile equipment applications.
Yeah, Helga, we have a brand new line, and as of the publishing of this podcast, Pepperl+Fuchs is the only company that does that. But it's a unique sensor output, and it is a 0.5 volt to 4.5 volt sensor line.
Let me interrupt you right there. You know, the structure of our podcast is typically we're motivating the reason. What is the problem we're trying to solve? So could you go into the whys of the product?
Well, Pepperl+Fuchs has come up with a new sensor line for mobile equipment primarily. And the problem that mobile equipment sensors can have is that if a sensor fails or a cable breaks or a cable shorts out, a mobile equipment controller can run and not know that's actually happened, because a typical 0 to whatever the supply voltage is, normally 12 volts on a mobile equipment application, sensor will either see a 0 volt or a 12 volt signal. And if it does not know that that's a good signal, as opposed to a failed sensor or a short or a broken cable, it won't know that it has a bad signal coming into it, and it will just treat that as an input.
Yeah. So it's about diagnostics. It's about diagnostics.
Yes.
and optional reliability. That's what we're after.
Yes. And what Pepperl+Fuchs has done to help with that problem is we came out with a line of 1.5 volt to 4.5 volt sensors. And those sensors for a 0 signal or no target will put out a 0.5 volt. And for a target at present, it will put out a 4.5 volt signal. So the controller knows.
Okay, so we immediately know at a 0.5 volt, the sensor is doing something. It is no target, it is doing something, but it's different from no voltage at all.
Exactly. And that's pretty typical on other mobile equipment type sensors like oil pressures, speeds, distances, anything like that. You'll usually get that type of a signal. The controllers are used to that, so it's not something that has to be a completely new technology that the mobile equipment industry has to be used to.
Oh, excellent. So we're following a mobile equipment standard. It's just that our inductive sensors, or our present sensors, I should rather say, are unique, as in we're following this well-established mobile equipment standard.
Exactly.
Great.
Something the industry's used to already, and this actually isn't a technology that's new for us. We've done this pretty much the same way with our Namur sensors for decades now. The Namur sensor has definite set points that go into an intrinsic safety barrier, and
different markets, different applications, similar idea.
Yes, you'll know when you have a cut cable or an open cable or the sensor is bad. So
yeah.
This is just something new for the inductive sensor line for mobile equipment that ensures that their customer will know definitely what a signal is when it gets to a controller.
Okay. So could you, you did say that this was a family of products. So what is part of that family?
Well, we have inductive proximity sensors. That is probably going to be the main part of this line for us. We also have a Hall effect sensor that is typically used for speed measurement. And this one's a little unique because it also has a direction output on it. So you'll get a pulsed output for picking up a magnetic target on a shaft or whatever the customer wants to look at that has a magnet on it. And then another output will give you a signal to tell you what direction the shaft is turning in. So that one's a little bit unique.
Okay, is that sorry for interrupting there, Jim. Is
okay.
that direction output a separate output, or are we coding the direction signal on the single output line?
That one is a separate output.
Okay.
So that sensor will have two outputs on it.
Okay.
Now the last one in our family is an ultrasonic sensor. So the ultrasonic sensor, typically you'd see for a voltage output type ultrasonic sensor, you would see a 0 to 10 volt DC signal. This will work the same way, except the signal will be a half to 4.5 volt DC.
So therefore, this is an analog output sensor. It provides a range of distances.
Yes.
Okay.
And that voltage range like that is typical in the industry. You will have a 4-volt span on this sensor. So for an example, you can have at 0%, you would see a half a volt, and at 50%, you would see 2.5 volts.
Mm-hmm.
At 100% of distance, you'd see the 4.5 volts. So that's a pretty common way to tell distance in the industry.
Okay. Now, when we're working in the mobile equipment space, then we always have to be concerned with the general environment, which is very, very rough. So there is
Absolutely.
a thing called the E1 rating. Where do these sensors fall in terms of toughness?
Well, these sensors are extremely tough. I mean, they have, as far as EMC goes, they're 3 times a normal proximity sensor. They have thicker cables than a typical proximity sensor or a sensor family like that. We can also make these with either just regular 2-meter cables, or we can make these with pigtails with overmolded mobile equipment specified applications like a Deutsch connector. Those seem to be pretty common. We can put pretty much any kind of connector that the customer wants on it easily.
Okay, so it was designed from the ground up with all these thoughts in mind for harsh mobile equipment applications.
Absolutely. And just as a side note, because these sensors put out less than a 5-volt signal, they can also be used in applications where you have small single board controllers like an ESP32 board, an Arduino, maybe Raspberry Pi. We start to see those in the industry to run small bots and things like that companies are starting to come out with. Instead of having a full-blown controller, companies will use these ESP32 based single board computers or controllers to run their equipment with, and that's kind of exciting because that's a big industry that's starting up now. Typically, these bots are just small versions of mobile equipment, so we're kind of excited about that also.
Okay. What about stock? Can you talk about our stocking policy and what do we have to consider when someone wants a special?
If somebody wants a special, we have a group of people that have been at P&F for quite a while that will actually go through and they'll get with the customer, talk with them, and we call this our custom applications group. They can modify these sensors to fit the customer's application. It's mostly with the connectors. Those are very easy applications to fulfill. We have a very good group overseas in Europe that does our connector applications and cabling for us. So special applications are no problem.
Perfect. Anything else that our audience should know about these products?
So yeah, Helga, I just want to remind our customers that P&F did invent the inductive sensor, and we have a very, very extensive line of mobile equipment sensors.
Yeah, so Jim, on that topic of having an extensive portfolio, I should also remind our listeners that we have a radar and an ultrasonic sensor for mobile equipment applications with a CAN interface.
Yeah, we do, Helga. Actually, our CAN interface J1939 line is actually growing, and right now it's pretty extensive and pretty comprehensive. You asked why customers should run with P&F. We have a very extensive line now of mobile equipment sensors. If you look inside our sensors. Our sensors are fully encapsulated in epoxy internally, and we use different types of epoxy so that moisture weepage from atmosphere cannot get to the PC boards and corrode them. They have different types of epoxy on the PC board so that that's flexible and doesn't cause components to be pulled off the board from the epoxy as the sensor heats up and cools down. And all of these sensors here that we're talking about today are rated with mobile equipment specs. So that gives you higher EMC rating, more shock and vibration, and these were designed to be on mobile equipment, pieces of equipment.
Very good. Okay, so Jim, you know the drill. We're closing this out with a 5-word ending statement, the takeaway. And while you think about it, I'll try to summarize what we discussed. And, if I make some mistakes, by all means, do correct me. So particularly today, we're talking about a line of sensors, a Hall effect, an inductive, and an ultrasonic sensor that has a mobile equipment output scheme where the sensor operates between 0.5 volt and 4.5 volt on the output side. And the reason for doing that is to give a mobile equipment controller a positive feedback when a sensor is in the open state, but still connected, 0.5 volt, and it can therefore compare that to 0 volt, meaning cable got cut, sensor got removed, or a short where it would go to the supply voltage, 12 volts, for instance, and therefore there's a higher level of functional reliability. That is really the gist of this output scheme. Now, on the Hall effect, because it's a speed sensor, we have a second output I learned today.
Yes.
That provides a directional signal, which is also very, very nice. And then you mentioned that we have, in general, for the mobile equipment market, a very broad portfolio. J1939 is a protocol that we see more and more. We have radar, we have ultrasonic on CAN, on J1939, and there's a whole bunch of others. All our mobile equipment sensors are designed specifically for this harsh environment, which means we're taking care of load dump, we're taking care of IP, we're taking care of encapsulation in a way that the sensor survives frequent temperature up and downs, water, all the nasty environments that something on a machine could see. So that's how I would summarize it.
Yep, I think that's a pretty good summary of the sensors that we have just come out with here. So you asked for a 5-word ending, and
yes.
I thought about this, and I think because these sensors and this whole family now that we have is leaning toward giving positive indications to your controller, I'm going to go with positive status prevents control issues.
I like that a lot. I like that very much. Yes, it is at a minimum a tri-state sensor, and so there is more positive feedback to the controller. Excellent. Positive status prevents control issues. I like that a lot. Well, Jim, thank you very much for spending some time with us today. And I hope this is a useful episode for our audience. And I want to thank everybody for listening to Pepperl+Fuchs Plugged In. Thank you very much. And thank you, Jim. Bye-bye.
Yep. Thanks, Helga. Bye.
We hope you enjoyed this episode of Pepperl+Fuchs Plugged In. Please subscribe to our channel and never miss hearing about the latest innovations in factory automation.